Let's begin. Write each of the following in the form log BA equals C. Okay. What I know is this here is the number that's being squared. Okay. The power is always the small 2 ends up on the left side, the 10 ends up on the bottom, and the 100 ends up on top every time. If I want to do this one here, okay, the 27 is the tree is this tree here is the power. The big tree is the base. This is the number we're trying to create, and that's it there. Log 27, the base tree is 3. In English, that means what power of 3 would you need to use to turn it into 27? 3 to the power of 3 is 27. Okay, finally you'll go on to number 8, and you go, okay, once again, the base is 8, the power is 0, so log 1 to the base 8 is 0, because 1 equals 8 to the power of 0. Now guys, I've got to ask you a general question. What's log 1 to the base absolutely anything? 1. Always 0. Because anything, any number, excuse me, I got that wrong. Nope. Excuse me. What I'm trying to do here is 1 equals any number to the power of 0. You got it? Any number to the power of 0 is 1. That means this here can be any number, and it will log 1 is always going to be 0. Okay, do you got that? Because any number to the power of 0 is always 1. That's the reason for that. Okay, number 4. Evaluate each of the following. Okay, so evaluate. That'd be interesting to actually see what they mean by evaluate. Okay, what we're going to do is we're going to get our set of rules. First one, evaluate the following. Log A to the A squared. Okay, now the problem here is we're going, okay, it's A squared. I know that any number to its own base is 1. So remember we said earlier, guys, log 10 to the base 10 is what? 1. Because 10 to the power of 1 is 10. What's log 5 to the base 5? 1. Also 1. Log million to the base of million? 1. Log A to the base A? A. No. 1. Any number to the same base is 1.
If that's not the same number, it's number multiplied by itself.
So look, A equals A to the power of 1. In the same way, 5 and 5 equals 1 is basically 5 equals 5 to the power of 1.
Yeah, but it's not A squared.
I know, just give me a sec, I do know that. Okay, so the reason why I'm choosing this method is I don't know anything about A squared. Okay, so if I was to go through the same logic, okay, what's log 5 squared to the base 5? It's basically, it's log 25 to 5, which is, anybody? 2, because 25 equals 5 to the power of 2. Does it work for tens? What's log 10 squared to the base 10? I'm basically asking you is log 100, haven't I? And log 100 is 2, because 100 equals 10 to the power of 2. By this same logic, you would assume that the answer to this question is 2. There's a way of proving it though, okay? I'm going to show you. There's a rule here. The rule here is this one here. Rule 3. Is everybody looking at rule 3? Yeah? Rule 3. Now rule 3 says that log base A x to the cube. So basically A equals A. The A from this matches the A here. X also equals A, doesn't it? In the x's position we have A, don't we? And in the q's position we have 2. Long story short, when you have a power, you can bring the power to the front. So the answer will be log 2 log A base A. What's A to the A? 1. 2 times 1? 2. If you aren't sure about that rule, just think about the example I gave you a second ago. Log 10 to the 100. What is log 100 base 10? 2. I could change 100 into 10 squared. Then I can enact this rule that brings it to the front, and then it's 2 times log 10 base 10. And what's 10 base 10? 1. 2 times 1? 2. You can see it's just a makeover, but it does the same thing. Simon does a nice way there, as in he looked at this and goes, look, log a to the a squared. I could say, call it x. And then I bring the a up, and then I'm left with a squared equals a to the x. X therefore must be 2. The answer is 2. That's another really good way of doing it.
So that means question 2, the answer would be 3?
I'll get there. The answer is 3, yeah, right. Yeah. You go.
How does A to A?
Alright, guys, another way of looking at it would be this, okay? It'd be going log 5 to base 5 equals x, yeah? This 5 here equals the small 5 to the power of x. 5 to the power of 1, x therefore is 1. This means that log 5 to the 5 must be equal to 1. Is that any better? That's the only way to explain it, is that whatever number this is, it has to equal the base number to the power of whichever number is on the right hand side. That's the way it works. Okay, it's a learn off. Okay? Now, let's try another one. We already know that this one here is going to be, anybody? You can bring it to the front and you get 3 log a to the a, 3 times 1, which is 3. That's fair enough. Okay, let's try another one. I'm going to try part 4. Now, part 4 has 2 things in it. I want you to look at law 1. Law 1. Law 1 says log a xy equals log ax plus log ay. I want you to note one thing. The base number is always the same. You can only do rules 1 and 2 when the base numbers are the same. They have to be the same. So here we go. 25 and 15. Ignore the second part, okay? So what happens when 25 is going to be called what? 25 is x and y is going to be 15. Okay? So it's going to be, and what's a going to be? A is 5. So it's 5 bracket. We got to multiply 25 by 15.
That's being divided.
No, we got to multiply it because it says xy. Xy means it's a plus sign in the middle.
Oh, I thought it was a minus sign.
Guys, please. This rule here is the addition rule. Rule 1. It's a plus. I ignore the third part. I ignore the power. I'm ignoring all that. I'm just purely concentrating on log 25 to the base 5, log 15 to the base 5. In the a's position of the rule is the number 5. That means anywhere I see a, I put 5. X is the first number that I'm adding. X therefore is 25. Y is the second number I'm adding. Therefore y is 15. XY means 25 multiplied by 15. Okay? Just follow the rule rigidly. Then we're going to get log 5. And what's 25 times 15? 375? Yeah. Okay, 375. Now, thus far, I've only taken care of this little part here. I still have minus log 5 to the base 3, and I still have a power to contend with on the outside. Is that right? Now, let's deal with the minus rule. What's the minus rule? Instead of adding them, you divide them.
375 divided by 3.
375 divided by 3 is excellent, Connor. That's exactly what we're doing, okay? When you have 2 bases that are the same, and you're taking away two logs, they have the same base. This means a is 5, so log 5. and the x goes on top. X is 375, and 3 is the bottom. And that's to the power of, still the power of 4. And what we're going to get here is log 5 to the 120, 5 to the power of 4. Now, bring the 4 to the front. 4 log 5, 125. Now, you can just think in your head, 5 to the power 1, 5 to the power 2, 25, 5 to the power 3, 125. What can you tell me about log 5, 125 to the base 5? 3. 4 times 3? 12. That's it.
Sir, you get what you did, but why didn't you remove the brackets?
Evaluate log P over Q plus log Q over R. There's actually 2 ways we could do it. The first way we could do it is like this. Go backwards. Log P over Q is log P minus log Q. Which rule am I doing there? Second rule. And what about this one here? Log
Q.
Minus log R. And then finally the last one. Log R minus log P. And what happens to them all?
Cancel.
Answer is 0. Another way of doing it, and everybody got that? Another way of doing it, and you would be entitled to do it this way, it's slightly more complicated though, is I could call this one X and this one Y, and I can do the multiply rule. So I'd have log, what's PQ multiplied by QR? PQ divided by QR? It's P over R. So that this part here turns into log P over R, and then I'm adding in log R over P. I can now multiply the two of these by each other. What's P over R by R over P? 1. It cancels, don't they? So it's log 1. And what do we know about log 1?
0.
Always 0. 2 different ways doing the same question, okay? Now, number 7. Using the fact that log A, it gives us the rule, by the way, so that's actually really nice of them, alright? Now, I'm going to explain what this rule does, okay? Yeah. Yeah, got it, okay? Log 27 and 81. Let's match it up. Okay, match up this part here to this part here. Which letter is A? Or which number is A?
81.
Which one's B? 27. The problem here is your choice of C. What would be a good choice for C? Now, lucky for you, you could do it in your calculator quite easily. But, and it doesn't matter what you choose for C, but what would be a really good choice for C is a number whose power system goes through 27 and 81. What I mean by power system is this. Do you see what I'm doing? 27's in there, and so is 81. So I'm going to let C be equal to 3. Let's use the rule rigidly. Log base 3, A is 81. Log 3 to the base 27. Now what power is needed to make 81? 4. What power is needed to make 27? 3. The answer is 4 over 3.
You can put that in your calculator straight away.
I am aware of that. Okay?
You have to show it.
By knowing how to manipulate it as good as I do, it will make sure the next couple of exercises come across really easy as opposed to really difficult. Okay? Alright. That's that one, okay? Now, there's an expansion on this rule, okay? Then it would ask me, evaluate log BA, log CB, and log AC. Now, before I move on to this, I want to show you an expansion of this rule here. There's an expansion of this rule here, okay? And the rule is this. If you see, try and think now. Yeah, got it. Okay. Log B to the A. Okay? Now the rule is, this rule here says I can do log A to any base I want and log B to the same base. Yeah? Now, what happens if I choose the same base as the top number? Log AA, BA. What happens? What's log A to the base A? 1. And the answer is going to be 1 over B to the base A. Do you see the way, in essence, the two of these switched positions? Do you see that? So basically, if I get something like this, log x to the 3, I can do it like this, 1 over log 3x. That's a rule. That's the rule in part C. You're allowed to switch them around. And it comes from this here, that if I choose the same base, it will work out. I'll show you the longer version of that now. The longer version is this. If I have log, let's go x to the 4. Okay? The rule is I can do log any base I want, x on top, log any base I want, 4 on the bottom. What would be a good base to choose to turn the top into 1? X. And you get 1 over log x to the 4. And you're basically changing positions of your two numbers here, okay? That's the way it works. Alright guys, with that in mind, you're looking at this next question here. Now what can you do with this? Okay, they all have different bases, don't they?
Yeah.
That's a bit of a problem. Can we agree to change them all into the same base? Which base would you like me to change them into? A, B or C? I have a choice. There isn't a wrong choice. A. Okay. Log B to the A. And then I'm going to do the next one after that is log C to the B. The one after that is log A to the C. Okay, let's change them into, we want base A's, don't we? Okay, so let's see about base A's. Okay, log A over log B, log B over log C, and then the last one is log C over log A. And then I can choose any base I want. It doesn't even have to be A. I could turn all them into 10s. It doesn't matter, but I'll do A, like I suggested we do. A, and A. Okay. Which ones turn into 1?
The bottom.
Okay. Now we're going to multiply them by each other, like it asked me to do it. So I'm going to multiply 1 over log A to the base B. Oh, sorry, B to the base A, excuse me. This one here is log B to the base A, log C to the base A, and then finally at the back we're going to have log C to the base A all over 1. And what do you notice about all the numbers? And the answer is 1. So it looks very difficult.
Couldn't you almost tell me one from looking at it? But
I'm not that good now. I'd actually have to bash it out. Yeah. Some of you's that good, fair play to you, but tests go on shown work, which equals marks. Okay.
you know that there was going to cancel the
Collard. What you got to remember about logs is we've learned in the past that, let me see, 2x equals 10. Yeah? We would identify that both of these are even numbers, wouldn't we? And we would say, look, take 2 off both sides and say x equals 5. That is maths that works grand, provided we're not using functions. These increase linearly. If I double x, I double 5, don't I? Now, the problem with logs is this. Take 2 logs you know the meaning of, right? So we know log 2 to the base 64 to the base 2 is what? What power 6? No, 2 to the power 1, 2 to the power 2, keep going. It's 2 to the power 6. We know this answer is 6, don't we? Now, Let's think about this one as well. Log 2 to the base. We'll go for 2 to the base 32. What's 2 to the base 32? 5. The answer is, these aren't equal, are they?
No.
6 doesn't equal 5, okay? So I'm going to turn it in a way that they're equal to each other. I can do log, I need one more, don't I? To make it equal, so log 2 to the base 2. Balanced, yeah? Now what you're not allowed to do is this. Oh, the log 2's cancel. Is 64 equal to 34?
No.
So you're just after learning, you can't cancel logs, can't happen, okay? However, there is one thing where you can say something, okay? If I have this log, let me see, log 2, and this is x plus 30 equals log 2 to the 32. What can I say this time?
You can say that x plus 30 is equal to 38.
I can say x plus 30 equals 32. Okay? Because this time I'm not cancelling it because what's inside has to be equal to each other. Okay, so it's different. Okay? Now, what? So, what's going on here, guys, is this. I need to bring everything that has a log onto one side. So 3 log 2y minus log 2 x plus 4 equals 3. Now, is there a rule that allows for there to be a number in front of the log and then subtract them? What do you know is about rule 2? Is there any number in front of the log? No. You must match your rule really rigidly. This 3 is blocking all my fun. How do I... It's blocking the crack, lads, alright? Now, where do I put the 3? I use rule number 3 and I bring the 3 up to y cubed. Okay? And now all of a sudden I'm going, it's basically party time now because we're compatible, you know? So the log 2 and the log 2 is compatible, okay? So we're going to use rule number 2. So x over y. In the x position is y cubed, and in the y position is x plus 4. So we're going to get log 2 y cubed over x plus 4. All of that equals 3. What does this mean? If I was to tell you this, if I was to write down this, okay, something really easy, and we've done this already. If I was to tell you log 1000 to the base 10 is 3. What you'd then tell me is if you want to get rid of that log, you'd then tell me 1000 equals 10 to the power of 3. Let's do the same thing here. Y cubed over x plus 4 must equal 2 to the power of 3. What's 2 to the power of 3? 8. And then bring up the x plus 4 and we have our proof, don't we? 8 times x plus 4. Is that what I was asked for? It is. Okay, guys.